Go ahead.
So today we're going to be covering how to graph a function. So here's our function here, and the first thing we're going to be covering is the first derivative test to find critical numbers. So let's set f prime of x equal to 3x squared minus 18x plus 24. Now the next thing we're going to do, we're going to take out a 3 and set this equal to 0 to find critical numbers. So this is going to be x squared minus 6x plus 8 is equal to 0, and this is factorable. So this is going to be x minus 2 times x minus 4 is equal to 0. If we set both of these equal to 0, we find that our critical numbers for this function are 2 and 4. So to find whether these are local minimums or local maximums, we're going to use a number line and plot both our numbers. And we're going to choose numbers that are below or above each of our critical numbers. So let's plug 1 in to this function here, and let's see if we get a positive or a negative number. So if we put 1 in here, it's going to give us -1, and this will give us -3, and 2 negative numbers gives you a positive number. So if I plug in 3 here, this gives us a positive number and a negative number, which gives you a negative number. And if I plug in any value higher than 4, it's going to give us a positive number. So due to the first derivative test and critical numbers, we can say that since this is increasing and this is decreasing, and then here this is decreasing and increasing. So this gives us great information that we're going to be using to graph our function. Now, the next thing I want to cover is the second derivative test, to find the intervals of increasing and decreasing concavity. So let's say that f prime, double prime of x is equal to 2x minus 6. Let's set it equal to 0, and we see that 6 is equal to 2x. Divide each side by 2, and you find that x is equal to 3. So let's do another sign chart to find our intervals of concavity. So we have the number 3. If we plug in a value less than 3 into here, we're going to get a negative number. If we plug in any value higher than 3, like 4 for example, it would be 8 minus 6, which is a positive number. So due to this, we know that we have an inflection point at 3, which means that at 3, this function will change from decreasing to increasing. So now that we have these things, we can go ahead and we can make a number chart with our x and y values. So this is on an open interval. We're going to just start with these 3 numbers here. So we have 2, 3, and 4. We're going to plug each of these values in to our first equation, and we're going to find what the y values are. So if we plug in 2 here, this gives us 8 minus 36 plus 48, which is going to be 28 plus 48. So that's going to be, so now with all this information, we're ready to graph our function. We know that it's going to be increasing from negative values, so let's start to draw that. And we know that when it hits the point at 2, it's going to start decreasing, and when it hits our inflection point, it's decreasing, and then when it goes to 4, then we start to increase again. So this function is going to look something like this.
Action.
So we had our function, we used the first derivative test. That gave us our critical numbers, gave us intervals of increasing and decreasing concavity. Then we moved over to our second derivative test, which gave us the intervals of increasing and decreasing concavity and inflection points. We used our number chart, then we graphed our function. That's all.
Say thank you.
No. Thank you.